so not similar. The next case, we have LMN and JKN. Are those similar? I see that they have vertical angles equal, and then we want to check MN is 15, MN is to NK, so that would be 15 is to 3, as 18 is to LN is in the same position as JN to 3.6. So 15 divided by 3, 15 divided by 3 is 5. Is 18 divided by 3.6 5? Yes, indeed. So these would be similar by side angle side for similar triangles. Okay, and then the next set of triangles, would these two triangles be similar? Well, I already see that they have angle A and angle C equal to each other. Then, since those two lines are shown as parallel, we know that alternate interior angles are equal, so they have that set of angles equal. Therefore, they would have all three pair of angles equal, they would be similar. So ABC, and CDB are similar, so they even have it in the right position. Okay, so let's just revisit then the similar triangle, the ways to prove that triangles are similar. So given that triangle ABC is similar to triangle ADE, we know that they have corresponding parts. So that was the first thing that we said, that all of their corresponding angles are equal. So the angle A, so notice angle ABC is right on top of angle ADE. They share angle A, so angle A equals angle A. This angle at vertex B is equal to this angle at vertex D. And the angle at vertex C here is equal to the angle at vertex E. Now, all of their corresponding sides are proportional. So we have AB is to AD. So that's that whole overlapping side, as BC is to DE, as AC is to that whole side over there, AE. Okay, so that's the corresponding sides of similar triangles being proportional and corresponding angles are equal. Okay, so if we know, let's do a proof here. If we know that SG is parallel to CD, if those lines are parallel, could you prove that these two triangles were similar? I think this is almost too simple to even set up. So given, but I'm going to do it anyway. SG is parallel to CD, given. Now, how do you prove the triangle is similar? Well, just show that two pair of angles are equal and you have it. So we could use both pair of alternate interior angles actually to make it easy on us. We could say that angle C is equal to angle G, and we could say that angle D is equal to angle S, because alternate interior angles of parallel lines are equal. So we also know that those two angles at vertex H are equal, but we don't need to use it because angle says you just need two pair. So triangle CHD is similar to triangle GHS because of angle for similar triangles. Okay, so then the other two ways to prove that, bear with me guys. The other two ways are to show that two sides and then included angle, just like when we had congruence, but this time the sides are going to be proportional to each other. So we would say this side is to this side. Instead of tick marks, I'm going to use little squiggles just to show that they're not congruent. This side and this side, say, we'd have to have the angle included between those two sides congruent. So that's what the side angle side pattern would look like. And then for side, we would have to have all three pairs of sides in proportion to each other. So, well, let me just give you an example. Let's say that we know that this is a 90-degree angle up here, and say this is, I'll use my famous 3, 4. If this is 3 and this is 4, and we know that this is 6 and this is 8, if we had right angles in between, we would check to say 8 is to 4 as 6 is to 3. Those are both a 2-to-1 ratio. So those two triangles are similar since the angle between those two pairs of sides are proportional to each other. So then if we had, just let me use the 3, 4, 5 and the 6, 8, 10 as my example again. We could see that the corresponding sides are all proportional to each other. So if I were to give you this question and say the measures of triangle AB, the measures of the sides of triangle ABC are 4, 5, and 7, and the measures of triangle XYZ are 16, 20, and 28. Are the triangles similar, and why? So I would set up a proportion, or I would set up the fractions, the ratios of the corresponding sides. 4 is to 16, as 5 is to 20, as 7 is to 28. And then I would check to see if those are all equivalent fractions. So we have 1 is to 4, 1 is to 4, as 1 is to 4. So we're good to go by side, side, side for similar triangles. Now, if these were mixed up in order, we would just match it up small, medium, large, and check it that way. Okay, let me just do a couple examples. I know this is running a little bit long. If we want to set up to find the length of AD and AC, we have to set up, because we're going to get to shortcuts in the next couple days, but today we have to use the corresponding sides of the similar triangles. So I would have 6 is to 21 as 8 is to 28. Do those two fractions reduce to the same, or are they equivalent fractions? So let's see, we would have 2, each divided by 2 over 7, each divisible by 3. Here we have each divisible by 4, so we would have 2 over 7. So indeed, those two triangles are similar because they share angle A. The sides that include that angle are proportional to each other. So these triangles, if these triangles are similar, can we find the value of x? Well, x is one of the sides of the big triangle, so I would have to use my scale factor. 12 is to 16, or 9 is to 12. You could use either sides there to get the same scale factor of 3 to 4. So 3 is to 4 as 8 is to x. So 3x equals 32. X is equal to 32 divided by 3, which is 10.6. Repeating. Okay, next. Solve for the value of x that would prove that triangle AMN is similar to triangle ABC. Well, we're going to have the ratio of the corresponding sides. So x is to 2x plus 10.5, because this is 2x plus 10.5, as 24 is to 3x plus 24. So then we're going to take a minute to cross multiply and solve here and see what we come up with. So we'll have x times 3x plus 24 is equal to 48x plus 10.5 times 24, 252. So what do we got here? 3x squared plus 24x equals 48x plus 252. Oh my gosh, we're going to have to factor, I think, here. So then we're going to bring that over. So we'll have 3x squared minus 24x minus 252 is equal to 0. Let's see, is 252 divisible by 3? 252 divided by 3, 84. So we'll pull out a 3, and we'll have x squared minus 8x x minus 84 is equal to 0. And then we could use the quadratic formula to solve this. Or what two numbers multiply to get negative 84 but add to give negative 8? Let's see. 84. So 7. Okay. If I can't come up with the numbers real quick, we're going to move on. Okay, 6 and 14. So x minus 14, x plus 6 equals 0. So the two values for x would be x equals 14 or x equals negative 6. X equals negative 6, we know in terms of our diagram, is going to have to be eliminated. So because the length of AM cannot be negative 6. So the answer to that question would be x equals 14. So that gives you a nice little practice with factoring too. Okay, I'm going to move on here. Last one. If we have to show, it says, here's a proof using similar triangles. Given that Fn is to An as Ni is to Nl, prove that these two lines are parallel. Okay, well, if I know that these two triangles are similar, then the corresponding angles are equal. So since I know that this side, Fn is to An as In is to Nl, and I know that angle 1 is equal to angle 2 because vertical angles are equal, then triangle FNI is similar to triangle ANL because of side angle side for similar triangles. And if that's true, then I know angle F is equal to angle A because of CASTE, corresponding angles of similar triangles are equal. And then our old faithful FI is parallel to LA because if alternate interior angles are equal, the lines are parallel. So we can even use similar triangles to prove lines parallel. Okay, for homework tonight, we're going to have in the same section as last night, that selection of 7 problems. Okay, and I believe there might even be an exit quiz online for tonight. So, or that one that you were supposed to do Friday, I think I canceled. So try to do that one tonight. Have a good day, guys. See you tomorrow.